welcome everybody. Hope we have a fun time together. Please do feel free to drop any questions, comments, or observations into the chat. I definitely want to make this as interactive a time as we can have together as we're going through this very interesting topic. Test automation has been recognized as a really important part of the Agile experience, mainly because it's kind of hard to do all the testing we need to do if we aren't using Agile or if we aren't using automation. But it's something that many people find difficult to deal with. So that's why we actually want to take this kind of a look at test automation and see how we can actually take a much more structured approach to actually making this happen. So just to take you back a bit here, we've been programming computers since, well, not quite the beginning of time, but definitely for a long time here. And it became clear the tools were the key to making things work, and that included test automation. But it wasn't until this millennium when Agile teams really started to see the need to get a better, more nuanced understanding of what test automation was. Agile teams found that they needed to automate, and test automation was just this big, challenging thing for them. And so that prompted the creation of the test automation pyramid. We're going to be looking at the test automation pyramid in this presentation, and we're going to go deeply into it, and we're also going to talk about some other things that are related to this test automation pyramid. The key thing to note here is that if we treat test automation as a single big monolithic problem, it's something we're not likely to ever be able to really master. Or if we do master it, it's going to be like way down the road, off into the future sometime. It's just not something we're going to be able to get to anytime soon. But that's the point here, is that we don't have to treat test automation as a single big monolithic problem. We can actually break it down into its many components and literally take the Agile approach, right? Break it down into small pieces, attack each of these small pieces one at a time. And that then gives us the ability to master much easier pieces much more quickly and work our way through until we finally achieved all the things we wanted to achieve, but done it in a much more realistic way. That's the Agile way of going about doing things, and we want to apply all we've learned about being Agile and approaching things in an Agile way. We want to apply that to how we actually automate testing as well. So that's the idea, and I'm referring to this as a structured approach, and it's really looking at it from an architectural standpoint. What are the pieces? What are the layers? What are the different things that we can break this down into to make it a much more manageable problem? So that's what we're doing here. There's actually 3 parts to it, and the pyramid is actually the third of those 3 parts. So we're going to start with the first part of this, which is how we design our applications. It turns out that a lot of the challenge that teams have with automating their testing actually have their roots in how their applications are actually architected. They're built in a way that makes them difficult to test. And so one of the first things that we have to do is, well, no, let me not put it as one of the first things. One of the things we need to do is to address the structure of our applications and really look at it from the standpoint of what is going to help us not only to build and maintain the applications, but also what is it going to take for us to be able to easily test them and indeed easily automate the testing of all parts of them. I don't want to call it the first thing because you have to deal with your existing applications. And the fact that it's built as a monolithic application and not structured the way we would want it structured isn't really going to be a reason for us not to start working on these things. But of course, if you're building something new, definitely you'd want to make sure that you have testability in mind as you're going through it. And the second thing we're going to look at is designing our tests for maintainability. Because the reality is that automated tests can be built in an architectured way, a way that has structure to it that makes it more maintainable. Just like the layers of our applications, you know, the user interface layer, the data layer, the logic layer, all these different layers in our applications, by segregating things, we make them more maintainable. The same is true of automated tests. So we're going to look at that. Then we will move on to the test automation pyramid. And in a test automation pyramid, it is a matter of looking at all the kinds of automated tests we can do, and again, breaking it down into its layers and working on one layer at a time. So these are the three things that we're going to be going through in this presentation. So part one, designing our applications for testability. And like I said, I probably shouldn't have called it part one, because this is going to be like the last thing you end up doing for existing applications. But it is an important part of it. When it's hard to test an application, that also makes it difficult to automate the testing for that application. So the first piece that we have here is using an appropriate architecture. We want to make sure that we're using modern architectural approaches, which essentially means not big monolithic applications, but structuring it using good object-oriented design principles here. Service-oriented architecture, microservices, essentially structures that are going to make it so it's not a single monolith that we have to deal with. These single monoliths aren't just more difficult for us to maintain over time, they are also more difficult for us to test. So we want to break them down into classes, break them down into services, break them down into microservices even, and that actually helps us to be able to test them more appropriately. We also, as we are breaking it down into these different pieces here, we want to make sure that we keep our object-oriented design principles in mind. And this is something that many of us have probably learned object-oriented design in school. If you're as old as I am, you learned it on the job, because back in school, they were teaching something totally different back then. But the bottom line is, all of us have learned this at some point or other, but we probably have forgotten it. And the reason why I say we probably have forgotten it is because of the fact that we design applications that violate the object-oriented design principles so often. There's just ample evidence that we don't do a good job of sticking with these design principles. And I have a smattering of them here on this screen. These are actually some of the more prominent of the object-oriented design principles. You know, the idea of loose coupling, the idea that things should be, when they need to have relationships, they should be related in a loose way, not tightly entwined with each other. Information hiding, right? Information that doesn't need to be public is private. All of those sorts of things. There's some of these that really stand out as more important than others when it comes to keeping things testable and keeping things simpler to manage and maintain. For instance, single responsibility. Right? Any individual object should have a single thing that it does. So I'm not going to go into all of these details, all of these different object-oriented principles. These are things that you can look up. And in fact, I have the URL over here for a really, really good reference for these principles that not only lists them, but actually describes them in some level of detail. But the point is here that if we design our applications using good structure and good object-oriented design principles, then that is going to help us to make them just that much more testable. I mean, that's really what it boils down to, makes them more testable. It's not something that if we aren't there, that prevents it. Like I said, your old applications are probably not well designed. That's okay. We can still do the other things we will be talking about here with those applications. It's just going to take a little more effort when the application itself is not designed in a way that actually promotes this. So this is The first piece here that I want to talk about is this idea of designing applications with testability, not just maintainability, but also testability in mind. All right. So let's look at the second thing. So the second thing is how we actually design our tests. Now, this idea of designing tests with a 3-layer architecture is something that was actually described in great detail by Jez Humble and David Farley in the book Continuous Delivery. I highly recommend that book. It's a great book. Really talks about the details of how to implement lots of the DevOps practices and tools. But it also has a lot of really good information on how to go about automating testing. In fact, it's probably, I consider that book to have the best treatment of test automation that I have seen anywhere. They actually have 4 different chapters, count them, 4 chapters on test automation in this one book. Really great stuff. And this idea of having a 3-layer architecture to how we actually design our tests is a big part of what they talk about there. And the reason for the 3-layer architecture is maintainability. You use a layered architecture to make something much more maintainable, and that applies to tests just as much as it applies to our actual creation of our applications themselves. So these are the 3 layers that they talk about there. The first one is the test definition layer. So this is the layer where you actually define what testing should actually happen, but you do it with a very business-like language. Many of us are probably familiar with this given, when, then structure that we're showing here. And this is actually a really good example of a test definition language that is very business-oriented and definitely not technical at all. The cool part about it is not only does it allow you to define the tests in business language, but it also means that the people who are involved in creating the tests don't really have to be all that technical. You know, I could have business folks who don't have a technical background at all. I could have testers who may not have the chops to be able to write test scripts in, in automated test scripts, but they can still define these tests with this test definition layer. By the way, there's a tool out there, Cucumber, that actually uses a 2-layer structure, and their test definition layer is precisely this. They use the given, when, then language as their test definition layer in their 2-layer architecture. So that's a real powerful thing there to allow essentially anybody to define the tests. And the second layer that they recommend is this application interaction layer. It's a layer that defines how to interact with the application itself. Literally what this layer is doing is a translation, taking each of the phrases from that test definition layer and actually translating it into the actual scripts or interactions with the application that are going to need to go on here. So giving the examples over here of what this might be translated into from the standpoint of converting it over into more essentially code, if you will, of what's going on. But they talk about separating the second from the third layer, which is what Cucumber doesn't do here. Separating the application interaction layer from the interface action layer. So essentially the application interaction layer is saying, well, this is how you achieve those things with this application, right? I have to log in as invoicer. I have to go to the invoice function. I have to create an invoice with blah, 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 right? How do you do those things? Through particular interfaces. And by separating the application interaction layer from the interface action layer, it gives you the ability now to use the same top 2 layers and then have different interface layers for using different interfaces. So for the web interface, for the mobile app interface, for the API, you can have different interface action layers that account for that and not have to make changes to the other parts of it. So you see what I mean about being maintainable, right? And if the application changes, well, that makes changes to this application layer and very likely no changes at either level 1 or layer 3. So this idea of a 3-layer architecture, You know, that's really what we're talking about here, is a 3-layer architecture that's going to allow us to separate concerns and essentially make tests that are much easier for us to maintain and easier for different members of our team to actually be involved in managing and taking care of. All right, so so that is the idea of a layered architecture and test. And like I said, this is kind of cool because we already have an example of a 2-layer architecture in Cucumber. And they're just suggesting go one step beyond what Cucumber does. All right, so let's go to the pyramid. So the test automation pyramid was actually created. So test automation pyramid was created by the Agile community, but it's gone through a lot of evolution. There's actually, I have no idea how many versions of the test automation pyramid are out there. I mean, if you Google it, you're going to find lots and lots and lots of versions of it. And so I have felt the liberty to go ahead and create my own version of it here, where I combine the best from all of the versions that I've seen out there, plus guidance from the continuous delivery book, and what Jez Humble talks about in this really good approach to test automation. So this is different from most any other version of the test automation pyramid you're going to see, because I haven't seen others that take into consideration the guidance from the continuous delivery book. All right, so first off, the pyramid shape gives us this idea of foundations and building on foundations, right? You have the foundation of the pyramid, and then the next layer up, and then the next layer up. So you build a foundation, and then you build on top of that foundation, and that becomes the foundation for the next layer up, and that sort of thing. And that's the first thing that's being communicated by the test automation pyramid, is this idea of foundations and building on foundations. And we're going to walk through each of these layers here and talk about what we expect to see at each of those layers. So that's going to be the pages coming up here. So I'm not going to bother with that right now, but I wanted to highlight the fact that they literally are designed to build on each other. All right. And then the other thing that's being pictured by this pyramid shape is the breadth of the pyramid is really indicating how many test cases we expect to see at each of these layers of the pyramid. Where you see the lower layers of the pyramid, where you're doing the more technical testing, we're expecting to see more test cases at that layer in order to actually achieve what we're trying to achieve. Just to give you a preview here, unit testing, we're trying to achieve code coverage here. If we're going to execute anything near 100% lines of code, it takes lots and lots of test cases to do it. And then as you move up the pyramid, then we're expecting fewer and fewer test cases, although the nature of the test cases change. And that's what we're picturing over here on the right-hand side. Because near the bottom of the pyramid, although we expect lots of test cases, we expect each individual test case to be relatively simple. And simple means easier to write, easier to maintain, and it also means they run fast, and they tend not to produce false negatives, where a false negative means, you know, didn't find a problem, but there actually is a problem, right? So towards the bottom of the pyramids, because of the simplicity of the tests, then even though we have lots of them, they don't represent a lot of work, and they also don't represent a lot of runtime because they run quickly as well. As you move up the pyramid through these different layers, the tests become increasingly more complex. And that means that they become harder to manage, harder to maintain. They become more brittle, so that minor changes in the application are likely to break the tests. They tend to run longer. The testing scenarios near the top of the pyramid tend to take a long time to run. The ones down near the bottom of the pyramid here, you could be talking milliseconds for some of them. Up near the top of the pyramid, some of them could run for minutes. I mean, literally, we're talking a huge difference in runtime. And also, when you get up near the top of the pyramid, you also are seeing false negatives become the rule. Because of the complexity of logic, when you get up near the top of the pyramid here, it's highly likely that you could have a defect, but have the test case miss it just by a little bit. Oh, if we'd just done it just a teeny bit different, we would have found that defect. So that's the idea here, is the tests near the top of the pyramid are hard to write, hard to maintain, a lot of false negatives. And that's why we want to push the automated testing down towards the bottom of the pyramid and have more of it towards the bottom and less of it towards the top, right? When you think about how many organizations approach test automation, they're actually focusing up here, the second and third layers from the top, right? And in fact, usually what you see is automated functional testing through the GUI, which is very, very problematic, very brittle, hard to manage. And the recommendation, this comes from, again, from the continuous delivery book here, is actually to split those two. I'll talk about that when I get to the page where I'm talking about those kind of tests. This is the big picture of the pyramid, all right? Divide and conquer. And that's really what we're doing, is dividing and conquering. So let's go ahead and look at unit testing here. So as I already said, our target in unit testing is code coverage. That's the gold standard for unit testing here. And the reason is very simple. If a programmer made a mistake in coding a line of code, that mistake is likely to become obvious the first time it gets executed. So unit testing should be focused on actually executing every line of code. All right, but what is unit testing? And I notice this says true unit testing. This is going back to the definition. Where did the word unit come from? We're talking about testing individual code units, not built into an application, but units by themselves. That's really what we mean when we say unit testing. Testing a unit by itself, not in the whole application. And that means that we're not really testing the interfaces. That's the next layer up on the pyramid. We're not testing databases. If this thing calls a database, I want to mock that. I don't want to actually hit the database. In fact, any external service at all, I don't want to be going and doing those things. I want to just be executing the code in this thing. So that means creating all various kinds of testware to allow me to exercise the unit and not be calling all these other things here, mock them out or stub them or whatever I need to do, so I'm not actually hitting all of those things. That's what we mean by true unit testing. And that's what enables us to come near or potentially actually hit this target of 100% code coverage. Right? The reason why you can't usually get anywhere near 100% code coverage is because you're executing entire applications and hitting databases and services, and there's just a whole lot of code that you find you just don't have a get to. So that's why true unit testing. Now, if we do that, then the foundation that we lay is correct code, right? The code does what I intended for it to do. And that's a great foundation. There's no dumb coding errors, right? The code as written is actually what I intended it to be. Once we have that foundation, then we can now move up to the next layer. So here, notice I'm at the bottom layer of the pyramid. So let's move up to the next layer. This is the automated API and interface testing. All right. So obviously an API is an interface, but the bottom line here is this is testing the interfaces. And I don't mean integration testing, I mean interface testing. Focus testing of the interfaces themselves, explicitly focusing on the interface. So for instance, if I expose an interface, then I actually want to be making sure that that entire interface contract has been implemented as it was supposed to. That's going to be a bunch of test cases, isn't it? Right? And how am I going to do that? I'm going to have to write something that actually uses that interface, uses and abuses it in every way I possibly can, right? That's what we're talking about here. Again, testware, right? And it's not just the interfaces I expose. What about the interfaces that I use, right? So any interface that my code is going to here, I want to test to be sure I'm interacting with that interface according to the interface contract as well. And that means now mocking out whatever that is that I was calling, and making sure that what I am sending is correct. And of course, whatever responses that it's supposed to be able to give back to me actually is some things that my code handles correctly. All right. So again, very technical look at this, and we're not looking at functionality yet. We're just looking at the interface contracts here. So the first layer was the code itself. The next layer up is the interface contracts. And have I actually implemented the interface contracts correctly? And that's the key here, is the interface contracts themselves. All right. So what this does, if I do that, on the first layer, I actually laid the foundation of correct code. And now on top of that layer, I am putting another layer of properly implemented interface contracts. So essentially, between these two bottom layers of the pyramid, what I now have is kind of the technical look at it, right? Code is precisely what it should be. Interface contracts are precisely what they should be. All right, so that's essentially the divide and conquer. Now we've made sure that from a technical standpoint, the code is correct. That then allows us to move up to the next layer. So the next layer is the beginning of functional testing. But here, I'm not talking about functional testing of the entire application, right? We're not really talking about integration testing yet. What we're talking about is testing each individual service or each individual method or function, depending on what architecture you're using in your application. But testing each one of those things, the functionality of those things now. I was talking about the interface contracts a minute ago. Now I'm talking about the functionality of every service that I've created, the functionality of every method that I have written, or every function that I have written, to make sure that the service, method, function, whatever that particular thing is, does everything that it is supposed to do. In other words, think in terms of requirements, but requirements down at the service level. Yeah, we got to think about requirements at the service level. And that actually is what we should be doing. When you're taking a system and saying, well, we're going to do this as a service-oriented structure or a microservice or whatever kind of a thing, you want to take the requirements for the whole application and then start distributing those requirements down to the individual pieces, the individual services or methods or whatever. And so that then would allow us to test the functionality of each of these things. All right. So this is where automated testing tools and the way that we have normally been talking about them start becoming really, really valuable, right? Those two lower levels of testing, you basically got to write your own testware. There are some tools that could be useful for those kind of things, but a lot of it is you got to write your own mocks. You got to write things that are going to call things, whatever. Here, you can start using automated testing tools. And obviously, a 3-layer architecture, as we talked about, is recommended at this level, even if you're using those tools. But the idea here is using sophisticated tools allows us to do a good job of testing the functionality. Right? And that is our target here, is we want to actually make sure that the capability of each service, the capability of each method and each function is fully validated before we put it all together into an application. So on the foundation we already laid before, correct code and correct interfaces, now we're talking about laying on top of that the foundation of correct operation of every single one of these pieces that are going to make up our application, the services, the methods, the functions that make up our application. All right, so that gets us through the bottom part of the pyramid. This is the first of 2 layers of the pyramid that are focused on functional testing. All right, the next layer of the pyramid, functional testing, is actually looking at the whole application. This is normally what we think of when we think of testing an application is, does it do what the requirements say it's supposed to do? Right? So now we finally get it. Where are we at? The 4th layer of the pyramid. And we finally get to what we normally think of as testing here. But here, we are talking about an interesting twist on it. And this is a recommendation directly from Jez Humble, directly from the continuous delivery. And that is, don't do that testing through the GUI. As I said, testing through the GUI has its complications, it's challenging, it breaks easily. And so essentially the recommendation that you have there is, don't do this functional testing through the GUI. Now, how can you do that? Well, the only way to be able to test the functional application, the functionality of the application without going through the GUI, is to expose all of the functionality of the application through APIs. And that actually is the recommendation. What he talks about is, when you architect an application, you want to set it up so that 100% of the functionality is exposed through APIs, and then the user interface uses those APIs, right? Because that allows you, first off, to separate the user interface from the application functionality, which is a good object-oriented principle, right? Don't embed functionality in the user interface, which has become common practice. Separate the graphical user interface from the functionality of the application. And then, of course, that allows us to test the functionality of the application without having to go through the GUI. So it simplifies our ability to test the functionality of the application, right? And here, of course, is where we are looking at, our target is this acceptance criteria, right? Making sure that all of the acceptance criteria have been met for the application. We're pretty far up the pyramid here. Remember, the breadth of the pyramid is supposed to be telling us about how many test cases we should have. Usually we throw lots and lots and lots of test cases at functional testing, but the reason for that is because we haven't verified these lower things. The reason for that is because we have lots of test cases in there that are actually about finding technical issues, coding issues, stupid mistakes that are easy to make at these lower levels. When we are building the pyramid like this, and we have that foundation underneath us that we have built here, that allows us now to focus our attention. And that means that the number of test cases that we have now is probably going to be smaller than it would have been. Essentially, at this level, the number of test cases we're going to need at this level is going to be driven by how many business scenarios and data scenarios that's going to have to be able to handle. All right, so that's really what we're talking about here, is focusing in on just testing to be sure the application meets its acceptance criteria, because all of the other testing, those other foundations have already been laid. All right, again, traditional automated testing tools are going to be a good approach for doing this. They're going to provide us with the capabilities that we need. And of course, use that 3-layer architecture in how you write your tests, but the traditional tools are a good approach for using this. And of course, now we are laying the foundation of, hey, the application actually does everything it's supposed to do, right? We now have an application that actually meets the acceptance criteria. Great foundation. What do we build on that? We can now test the GUI specifically. Now, this is an interesting one, because traditionally the GUI is just a way for us to get to the application. And if we're able to do all this functional testing of the application, the GUI must be good, right? Because we were able to run all of these other tests, so the GUI must be good. Well, with this mode, we have already tested the whole application. So now that allows us to turn our attention to the GUI itself and specifically test every widget in the GUI. So that's the interesting thing here. When we're talking about GUI testing, we're not talking about functional testing anymore. We already know that that works. Now we can actually focus in on the GUI. And this is something, this idea of 100% GUI coverage is something that I don't know if I've ever heard anybody talking about it. The reality is the GUI probably provides users with, a dozen different ways to do things. My favorite example is, think about Microsoft Word or PowerPoint, any of the Microsoft Office applications. Microsoft Word, how many different ways can you do a cut in Microsoft Word? Go through it in your head. How many can you come up with? There's a bunch, right? I mean, you can right click, right? And there's a little pop-up menu and you select cut from it. There's a cut button in the button bar across the top. Of course, there's the edit menu. Pull that down and you can select cut from that. You can do a keyboard shortcut, Control C or Control X, I'm sorry, for cut. You could write a macro. So I don't know how many that was. I think one time I counted 6 different ways or 7 different ways of doing a cut. But this tends to be the rule in a lot of our applications is we give our users flexibility. They can do things in a variety of different ways. Well, do we actually test every one of those different ways of doing things? That's what this is aimed at. Focused testing of the GUI means that we can actually focus on verifying every field, every button, every link, everything that you see on the screen and in the menus. Make sure that they all actually do the right things, that they gray out when they should gray out, that they disappear, that they appear, that they actually do all the things. If I have a drop-down list or a pop-up list, I can have specific tests to make sure that that thing is always populated correctly. So this now is a level of testing that we often don't get to. All right, and obviously automated tools are a good way of doing this thing as well. Although verifying, the things are visible and not visible and the content of the drop-down menus, it's not something we normally use these tools to verify, but we can definitely go that direction with it. And that then gives us a tremendous amount of power to make sure that the GUI itself is actually correct. So now we have a foundation of correct code, correct interfaces, correct functioning of our services, methods, functions, correct functioning of the application, and now correct functioning of our entire graphical user interface. But we're not at the top of the pyramid yet. What? What else is there? What else is there? Indeed, there's manual testing. And here, what we want to verify is anything that requires a person to look at it. And that's really what this comes down to. And the note we have here is if needed. Because depending on what it is you're testing, you might not have to have a person looking at it. And if you don't need to have a person looking at it, then you can completely eliminate manual testing. And obviously that's going to make everything move much more quickly. For traditional applications, we usually do need manual testing to verify things that a person needs to look at. Look and feel, is almost always going to be a human needs to judge that it looks and feels the way it should look and feel. Language things, if something needs to translate from, English to Spanish to French, whatever, these translations are things usually it's best to have people verify that the translations are correct. People who are familiar with the language, the different languages. So there's always a variety of things like that, we really do need a person to judge it. Now that's the top of the pyramid, because I don't want a person wasting their time verifying that something looks right or whatever if the underlying technical stuff is wrong for one reason. So that's why this is the top of the pyramid, because it needs to be built on this foundation of everything is as it should be, and on that you build your manual testing. So that's why, and you see this in every version of the test automation pyramid, the top of a test automation pyramid is always manual testing. That's where manual testing belongs, at the top. It's the last thing. It's the last thing you build if you need to build it, right? So the point here is investing human effort only for the things where that's the best way to verify what we're looking for. right? And that's the only thing, that's what we're saying here, is it's only when that's the best way to do it. If you can verify everything you need to verify using automation, that's what we want to do. But anything that needs to have a person looking at it, that's what we want to actually be using people to verify. All right. And of course, that then lays on the foundation the last thing, which is things that need a person to verify them have indeed been verified. So that's really what we're talking about here. And that gets us to the top of the test automation pyramid, which covers all of the pieces of what I wanted to bring to you today. So with that being said here, I want to open up for whatever questions we have here on any of these, whether we're talking about designing applications for testability, designing tests for maintainability, or the divide and conquer of the test automation pyramid.
There's one here, Alan. It says, shouldn't we be moving away from requiring any manual testing in all cases?
Moving away is probably the operative word here, because the reality is that we can probably find a way to automate almost any kind of verification that we want to do. But it's a learning process. And the reality in most organizations is we aren't even near that yet. You know, we haven't even come close to automating the things we already know we should automate. So I would say that that's probably a good general long-term goal, right? Moving away from manual testing of anything for most organizations. And again, depending on what it is that you are testing. So for instance, you know, one of the poster children in the DevOps community is Amazon. You know, they do, you know, thousands of deployments every day because they don't have manual testing as part of their process. Well, the reason why they are able to do that is because in their service-oriented architecture, there's actually very little that would even benefit from manual testing. Now, obviously, they do have a graphical user interface, but they have obviously found ways to do all the testing that they need to do, even things that have an impact on the GUI. They have found a way to do that in an automated fashion. So that's why I say.
And I would
go ahead.
Oh, and I would say as a product manager, it makes me nervous to think of absolutely no manual testing, right? I have such deep empathy for the customer that I always kind of want to make sure that I've gone through it with my customer's hat, no matter what awesome job my testing teams have done.
Yep. And again, it's a matter of where we go, because one of the things that we talk about in the DevOps community is the idea of having many very small updates going out instead of large releases. And so when we do that, it starts making it so that any issues that might cause any of our users heartburn or difficulty are going to have very small impacts on them. And so companies like Google and Amazon and those folks who don't really have manual testing as part of their process at all simply accept the fact that every once in a while they might push something out and people might hate what they push out, but then they'll push out a fix, you know, 15 minutes later. So, you know, so part of it is the whole DevOps philosophy of breaking what we're doing down into very small updates that are being done very quickly. And that reduces the risk associated with those things. But I do get where you're coming from. Yes, as a product manager, the focus is making sure we meet people's needs. And most organizations aren't there.
Yeah, I think it's just a comfort thing for product owners and product managers, right? Which doesn't at all mitigate the valuableness of absolutely testing all these little micro functions, because as you said earlier, there are so many things that a human could never catch all the variations and permutations of what's going on.
Yep.
Oh, hey, there's one last question here. It says, are you performing both smoke and E2E tests, and at what frequency and when?
That's a good question. So end-to-end tests are an important part of the functionality. So when you're talking about that automated testing of application functionality, that's where I would put end-to-end testing. Make sure that we can run through entire business processes end-to-end, make sure we can run through entire life cycle of data end-to-end. All of those kind of things would definitely be part of that testing. And then smoke testing definitely does need to be part of it. Hadn't really thought about where I would put that. I guess that would end up have to be functionality testing as well. But the bottom line, what frequency and when is a good question, because I actually didn't talk about that. And what we want to do is, again, take a page out of the DevOps book here and talk about building this into an automated deployment pipeline so that all of these tests are being run dynamically as people are checking things in. So essentially making it part of a direct result of people checking in any kind of a code change at all. And that's a DevOps concept, and I don't have the time to go any deeper into it, but just take a line, continuous delivery as a practice in DevOps, and you can really get a good picture of that.
Well, here's one of the nicest compliments I've seen today, Alan. It says, I am a tester of UI and prod without coding skills, and I'd like to express my gratitude that your presentation is so clear, even for people like me. So, job well done.
Thank you. Thank you very much.
Terrific. Thank you, Alan, so much for this. This was a great session, and I'm sure that all of the attendees here were able to take home some great nuggets.